We tend to think of science as this perfect, straight line to the truth, right? But what if I told you that some of the biggest leaps forward in history actually started with a big mistake? That's what we're going to get into today. How things like bad measurements, totally wrong assumptions, and even planets that were completely made up have somehow, accidentally, led us to some of the most profound truths about our universe.
It sounds kind of backwards, doesn't it? I mean, we're taught that science is all about being precise, being exact. But if you look at the history of astronomy, wow, it's just full of these messy detours and, well, happy accidents. It's a story where, believe it or not, some of the most incredible discoveries happen when scientists are out there searching for something that doesn't even exist.
And that brings us to the two main characters of our story today. First up, we've got a phantom planet, one that was totally imaginary but was born from a very, very real problem. And our second character, a real world, a real planet that was found completely by accident through a total misunderstanding. Yep, this is the tale of Vulcan and Pluto, and you'll see how their totally different stories tell us so much about how we actually find the truth. All right, let's kick things off. We're going back to the 19th century, where there was one planet in particular that was giving astronomers a massive headache, and that planet was Mercury. See, they had mapped out its orbit with incredible, incredible precision, but there was this one tiny detail that just wouldn't fit their calculations. Something was definitely off.
And when I say tiny, I mean tiny. The discrepancy was just 43 arcseconds per century. So what is an arcsecond? Okay, imagine a single degree in a circle. Now divide that by 3,600. That's 1 arcsecond. We're talking about a ridiculously small wobble in Mercury's orbit, one that you'd only even notice over 100 years. It was almost nothing, but, and this is the crucial part, it wasn't zero.
And that's the thing about physics, right? These tiny, unexplained leftovers, they're dangerous. They're like that one loose thread on a sweater. You just can't help but pull on it, and if you do, the whole thing might just unravel. This little 43 arcsecond problem was whispering to astronomers that something really, really fundamental was missing from their picture of the solar system. There was a piece of the puzzle they just couldn't see. So, what's the logical solution here? Well, you have to remember, astronomers had just had this huge, massive success story. Just a few decades before, they'd found Neptune. And get this, they didn't find it by looking through a telescope at first. Nope. They found it on paper, by calculating its existence based on wobbles in Uranus's orbit. So naturally, they figured, hey, the same logic must apply here. There has to be another planet, a secret one, hiding in the glare of the sun. They were so sure they even gave it a name, Vulcan. And just like that, the hunt for Vulcan was on. I mean, for decades, astronomers were absolutely convinced this planet was real. They'd point their telescopes right at the sun during solar eclipses, the only time you could possibly hope to see it. And people claimed they saw it. They'd report a tiny little dot moving across the sun. But Vulcan, it was a ghost. It never, ever showed up in the same place twice. Every single new observation just made things more confusing. But they kept looking. Why? Because that 43 arcsecond problem was real, and at the time, Vulcan was the only answer that made any sense. So it turns out the answer to Mercury's weird behavior wasn't going to come from a bigger telescope or a better lens. Nope. It was going to come from a complete and total revolution in how we think. A brand new way of seeing the universe itself. The problem wasn't a missing planet. The problem was our understanding of gravity. Then, in 1915, this guy named Albert Einstein comes along and publishes his theory of general relativity. And I mean, this idea was radical. He said gravity isn't some mysterious force pulling things together like Newton thought. Instead, he said that massive objects, like our sun, literally bend and warp the very fabric of space and time around them. Think of it like a bowling ball on a trampoline. And planets, well, they aren't being pulled. They're just rolling along the curves. And this is where you really see the power of a new idea. Because when Einstein took his new equations and applied them to Mercury's orbit, something amazing happened. The math predicted a wobble of, wait for it, exactly 43 arcseconds per century. It was a perfect match, all explained by the sun's massive gravity warping spacetime. And just like that, poof, Vulcan wasn't needed anymore. The planet vanished not because someone proved it wasn't there, but because the entire theory that demanded its existence was suddenly replaced by a much, much better one. Okay, so you'd think that after the whole Vulcan fiasco, science would have learned its lesson about just inventing planets to solve problems, right? Well, history has a funny way of repeating itself, because way out at the other end of the solar system, another mystery was brewing. And this one would lead to a result that was, frankly, even more bizarre. So here's the setup. Astronomers started noticing that the orbits of Uranus and Neptune seemed, well, a little off. Sound familiar? Just like with Mercury, there were these tiny little wiggles in their paths that just couldn't be explained by any of the known planets. And so what did they do? They went right back to the same playbook that worked for finding Neptune. They proposed another unseen world, a mysterious planet X, a huge, massive planet they figured must be lurking out there in the darkness beyond Neptune. Now, this search for Planet X became a real obsession for a wealthy astronomer named Percival Lowell. I mean, he was so convinced it was out there, he built an entire observatory just to find it. He passed away before he could, but the search continued. And in 1929, they hired this young, incredibly patient observer named Clyde Tombaugh. His job? For an entire year, he sat there painstakingly comparing photographic plates of the night sky, looking for one tiny dot that moved. And then, in February of 1930, he found it. They did it. Planet X was found. Celebration, right? Well, not exactly. See, the moment they started actually studying this new object, which got the name Pluto, they realized there was a huge problem. It couldn't possibly be the massive giant they were looking for. It was tiny, way too small to have any kind of gravitational tug on giants like Uranus and Neptune. They'd found something, all right, but it was basically the right answer to completely the wrong question. And if you think that's the end of the story, hold on, because here is the final, absolutely incredible twist. Years later, with much better technology and new data, specifically from the Voyager 2 spacecraft flying by, astronomers were able to recalculate the masses of Uranus and Neptune. And when they plugged those new, super accurate numbers into their equations, the orbital wobbles just vanished. They had never been real in the first place. The entire decades-long hunt for Planet X was based on a simple measurement error. Okay, so let's pause for a second and bring these two incredible stories together. On the surface, they look almost identical, right? You've got a problem in the sky, an anomaly, and it leads to a big hunt for a hidden planet. But as we've seen, they teach us two wildly different lessons about how science actually works. Just look at how this all breaks down. In the case of Mercury and the hunt for Vulcan, the data, that 43 arcsecond wobble, was totally correct. It was the theory of gravity that was wrong, or at least incomplete, and that led them to a phantom planet. But with Uranus and the hunt for Pluto, it was the exact opposite. The theory of gravity was perfectly fine, but the data, the measurements of the orbits, was wrong, and that led them to accidentally stumble upon a real world. The crazy part is, at the time, science had absolutely no way of knowing which kind of mistake it was making. And really, this is what scientific progress actually looks like. It's not that clean, straight line we imagine. It's messy. It's about making a guess, testing it, and most importantly, being willing to be spectacularly wrong. Sometimes the mistake is in your theory, other times it's in your data. The goal isn't to be perfect right out of the gate. It's to build a system that's tough enough to survive its own errors and eventually, hopefully, correct them. And so in the end, we're left with these two legacies. Vulcan is a ghost story, right? A reminder that even our most logical, most well-thought-out ideas can be completely wrong. But Pluto is a monument to a magnificent mistake. It's a real place, a world we've now visited with spacecraft that was discovered by people looking for something that just wasn't there. It's still out there, circling the sun, a beautiful testament to pure, dumb luck. And all of this leaves us with a really fascinating question to think about. I mean, right now, today, scientists are chasing all sorts of new anomalies, especially in cosmology, things you've probably heard of, like dark matter and dark energy. So are these things the modern-day Vulcans? Are they just phantoms that are going to vanish when the next Einstein comes along with a better theory? Or are they the new Planet X? Are they the wrong questions that are accidentally going to lead us to stumble upon some incredible, unexpected, new truth about the universe? We don't know. And the only way to find out is to keep looking.